Hello, and welcome to the Fermion YouTube channel. Today we are taking a look at the Advent of Spin challenge. Before we do that, I'd like to introduce myself. My name is David Flanagan, although you may know me from across the internet as Raw Code. And the very kind folks at Fermion have entrusted me, I have no idea why, with the streaming key to their channel and and are allowing me to live stream my attempts at the Advent of Spin challenge. So today we're going to take a look at the Advent of Spin challenge number 1. Now, what is the Advent of Spin? Well, it is a series of small and trivial challenges to get you accustomed and acquainted with Spin. Spin being a framework from the folks at Fermion that allows you to deploy and build and deploy WebAssembly based microservices. Now, much like the namesake here, the Advent of Code, which I'm sure you're all familiar with, it likes to test your challenge. It likes to challenge your algorithm knowledge, your ability to solve complex problems in new and novel ways. The Advent of Spin is a little bit different. The Advent of Spin is here to give you challenges you can complete in 20, even less, maybe up to 30 minutes, depending on where your skill level is, but all accomplishable in a very short amount of time. And they're going to be released every Monday and Friday in December. So it's a really great way for you to learn Spin, learn WebAssembly, and deploy something while having a little bit of fun at the same time. That is enough waffle. So I'm going to share my screen. I'm going to show you the Advent of Spin repository, and I'm going to guide you through the first challenge so you can see how to get started. If at any point you have any questions, please feel free to leave them in the comment section, and I will do my best to tackle them as we progress. So here is the screen. You can go to github.com/Fermion, where you will find a repository called Advent-of-Spin. This repository at the moment has 2 challenges, Challenge 1 and Challenge 2. Challenge 1 was released on Friday, just past, and that is the challenge I'll be working on today. Challenge 2 was released today, and I will be tackling that on Friday as we release Challenge 3. So the way that I accomplish these challenges will be one day behind, giving you a little bit of time to attempt it yourself. If you scroll down, there's a little bit of waffle and preamble that just tells you more about the Advent of Spin. I've kind of summarized this at the start of this stream, so don't worry about reading it if you are pressed for time. At the bottom, you can click Challenge 1, and you'll see that we have a little bit of background and information, just so you know what you're going to learn from each of the challenges. There is a small specification which your application must pass, and there is a supplied test suite and submission process where all the checks will also be run on Fermion Cloud. And I'll talk more about how we built this and the way that we accomplish all of these checks in a later video, perhaps towards the end of the Advent of Spin. All right, so what is our first challenge? Well, the first challenge is here to introduce us, 1, to the Spin CLI, 2, deploying your first application to Fermion Cloud, which is free, by the way. Using the Advent of Spin test harness. This is going to be as simple as run and make tests, but I'm going to show you the tests and how we put them together. And then we'll walk you through the submission process. Why should you submit your service URL or your Advent of Spin code? Well, there's going to be prizes. So stay tuned throughout the rest of the Advent of Spin as we announce what those prizes are and what we're going to give them away for. There's going to be a bunch of fun challenges and categories that your code in your application could help you win some Fermion swag and other cool stuff. Okay, so our first challenge is we need to write a hello world. Now, there's a little bit of story here. The elves have decided that Santa wants to migrate away from AWS, which is, of course, the Arctic Web Services. But their legacy systems weren't built to be API first. And this is something that they want to build a proof of concept for first. They want to prove that they can deploy API first, API driven microservices using Spin to Fermyon Cloud. And our challenge is just to write Hello World, but as a JSON API. Now, the specification gives us a little bit more detail. First, we can write this in any language that we want. How is that possible? Well, because of WebAssembly. Anything in any language which has a toolchain to compile as code to a WebAssembly binary artifact can be deployed and run with Spin and Fermyon Cloud. So I'm not going to go too far off the beaten track today, and we will be using the Spin New helpers to show you how you can generate and scaffold new projects with Spin CLI. But at some point during this advent of Spin, I will definitely be going down the random language track to see just how interesting we can make things as we go along. Our application must return a header, an HTTP header, which is content type application JSON. And it must respond with a JSON payload which has a key of message and a value of hello world. Nice and simple. So we can go straight to Spin New. I'm going to do this in a couple of languages today. The first one I'm going to do this in is Grain. It's a WebAssembly native language, so it only runs as WebAssembly as the kind of runtime. The reason you probably don't want to use Grain beyond this challenge is just that the toolchain isn't there. As we'll see, it doesn't actually have the ability to encode or serialize anything to JSON at the moment. So we're going to be just kind of making it work. However, I think it's a very exciting and promising language in this space, and I can't wait to see where they are in 6 and 12 months from now. And then the second language, I'm not really sure yet. We'll either do Go or Rust, or perhaps we'll feel a bit brave. We'll see how the first language goes. If you are watching and you want to suggest a language that would be fun for me to write, Hello World API-driven microservice using Spin deployed to Fermyon Cloud would be, feel free to drop that into the comments too. And even if you're not watching live and you just want to see how I would do something in another language with Spin and Fermyon Cloud, drop it in the comments afterwards anyway. I will read them all, and it may help me make decisions for future streams. Nice. Okay, let's pop over to my terminal. And we are going to run, this is my 2022 directory. So I'm just going to do challenge 1, and then we'll run Spin New. Now, Spin New allows us to pick one of the starter templates to generate our Spin application. We can do it in C, Go, Grain, Rust, Swift, Zig, and then there's some Redis stuff as well. However, we're only going to focus on HTTP today. And I did say I'm going to start with Grain. So we'll do HTTP Grain. And I'm going to call this challenge 1 Grain. I don't need a description. The HTTP base is just going to be slashed at this moment in time. And the path, this ... is a wildcard. It means we want to send all routes to this component. And as we explore more with these Advent of Spin challenges, you'll see that we actually need multiple services to be able to reach the specification or the goal of the challenge. So we'll need to slice and dice the way that the paths are routed between the multiple components, but not right now. This gives me my challenge 1 Grain directory, where I'm going to go, and you'll see that I have a main.gr. This is a Grain file, and we have a spin.toml. So let's pop this open in VS Code. Inside of the spin.toml, we can see the details that we set, the name, the description. This is an HTTP trigger, so we need to have an HTTP request in order for this WebAssembly component to be spun up and then respond. And then we have a little bit of toml that tells Spin how to glue this together. So this breaks down into 3 components. We have our ID of this component and the main.wasm. This is the compiled artifact when we run the Grain compiler. You can see the build step here where we run the Grain compiler and specify that the output will be main.wasm. We're then using the Waggy executor. This is fine, you don't need to worry about that. This is just how you handle languages that aren't kind of purpose built with Spin's SDK. Grain isn't using an SDK, it's just a standard WebAssembly module. And then our root, which tells us to expand all paths to the one component. Yeah, we can save that, I guess. I just added some spacing, not a big deal. So if we pop back to here, we can run spin build. Now, the grain compiler can be a little bit slow, so this does take a little bit longer than I would like. However, we want to get it running first. So it just takes a few more seconds. He says with hope in his breath. It is a little slow, but it's early. They can make it they can make that faster. There we go. Okay, so if we do ls, you'll see that we now have main.wasm, and in fact now I can run spin up, and you'll see that I have some available routes. Localhost port 30,000. If I open a new pane, we get hello world. So this is not our API driven approach. This is the standard grain boilerplate code. So what does that look like? Well, let's pop it open. Grain doesn't actually have, it's got a standard library. It's not huge. And because it's WebAssembly native, it kind of just always assumes that we're going to print stuff out. So actually what we get here is our first header, a blank line, which denotes to the HTTP text protocol that we're now going to move on to the body of the response. And then we have our hello world here. Of course, this is not API first because we need JSON. There is no JSON encoding. So we're going to do this very, very hacky, which is to escape all the quotes in the world and close off our JSON. This is a valid JSON response body. So this, in theory, should work. So what do we need to do now? Well, we have to come back to here. We're going to do a spin build and a spin up, and we can pass -- follow -all. This just means that when this module is running, we want to see the logs in our terminal. And if we give this another moment, once spin up has run and we have the available route, we will do the curl request one more time. Alrighty. Now, oh, it's not a valid JSON response because I forgot to give it a key. So I'll fix that in a moment and we'll kick off the compile again. But what happens if we run make test? Oh, I didn't copy the test suite from the challenge repository. So let me do that now. This is code source. So I'm assuming you would clone the challenge repository. And in fact, if I were a smarter person, I would have started this project in the challenge repository. I did not. So I'm going to copy it from github.com, fermyon, advent of spin, challenge 1, and I'm going to copy star.hurl to here. And let's do this one more time. And I'm going to grab the make file. So now we have 2 hurl scripts, a test hurl, a submit hurl. I'll get to the submit one in just a moment. And we have the make file. The make file is just running the hurl test kit. And don't worry if you're not familiar with hurl. We're going to take a look at that in just a second. So our test suite here tells us that we got text.plain instead of application.json. And our JSON message was actually invalid. So let's fix these mistakes. So we do have text.plain. So we can do application JSON. And we need a key for this, which is message. So while this compiles, we'll take a look at our hurl script. So hurl is a very cool project that allows you to create a hurl file, which is just a text file. And we can describe one or more HTTP requests that we want to make and apply assertions against it. So all of the Advent of Spin test cases and test suites will be built using this hurl framework. You can see here, we do a curl on localhost port 3000. We do a blank line. This means we expect a response of a HTTP any 1.0, 1.1 to 1.2, doesn't matter, or 2 with a 200 response code. And then we do some assertions where we assert against a header and using JSON path to guarantee that we have a key of message with a response of hello world. So now that our root is back, we can run make test again. And this time we have success. Everything works. We passed the specification, which is wonderful. There's one more step or one more hurl request here. And this is a hurl script, which will post your submission to the Advent of Spin backend service. And all it does is submit your service URL. So how do you get the service URL? Well, first, we have to deploy our Fermyon. We have to deploy our Spin application to Fermyon Cloud. And to do so, you'll first have to run a Spin login and then a Spin deploy. The Spin login is just your OAuth dance. It's going to take you to the Fermyon Cloud website. You log in and it saves your token locally on your machine. I'm already logged in, so there's no point in me doing that again. But I can run Spin deploy. In fact, I'm not logged in. There we go. So I have to copy this code and click on device activation. It doesn't work in Alacrity. Wonderful. Cloud.fermyon.com device authorization. Okay. Cloud.fermyon device authorization. Log in and paste your token here and authorize. Go back to the terminal. And we're authorized. So now it is deploying our artifact, waiting for it to become ready, and then it will give us a URL. Now, if we pop back to the challenge, you'll see that to submit, we run hurl, and we have to paste in the service URL. So we can paste this command, go to the quotes, and we're just going to copy the full URL given to us by Fermyon deploy. Now, we can also test this with a curl, and we see that we get our JSON payload back. When we do the submission, like so, we get a success or you'll get an error message. What's actually happening is that there is another Spin application deployed to Fermyon Cloud, which calls your service URL with a variety of test cases to see if it passes. If it does, it submits your entry to the Fermyon team, and you will be entered in with your chance to win some swag and other prizes, which is pretty cool. So that is challenge 1 done in Grain. So let's pop back out and we'll do it one more time. So let's run Spin new, and I've not had any comments yet, so I'm going to just pick something on my own. And I'm going to go with Rust. Why? Well, because there is a Spin SDK for Rust, so we get a little bit more out of the box. 2, I write a lot of Rust, so I'm comfortable doing this application in Rust. I am very tempted to use Swift or Zig. However, I think I'll save them for another day. Because I've never actually written a line of Zig. It's just something that has my... In fact, I've never written a line of Swift either. But they both definitely pique my interest. But in the interest of time, and that we are 20 minutes into the stream, I'm just going to do this one more time in Rust, and we can take a look at the Spin SDK. So, let's call this challenge 1 Rust. We take all the same parameters. We're going to go to challenge 1 Rust, and before I get started, I'm going to copy star.hurl to this directory and the make file. So now we have a complete setup, and this looks almost the same as the Grain one, except we have some Rust code. So let's pop this open. And in our spin.toml, you will see that we don't need to specify the Waggy component, again, because we have a Spin SDK here. It configures our WASM file and our build. So it tells Cargo how to build this as a WASM release. If we pop open the source source file, you'll see we have the Spin SDK here, which gives some helper functions to interact with the HTTP request. You can do this in Grain, and I will do a couple more of the challenges in Grain, particularly challenge 2 probably, so that you can see how to get request variables and such. It's very painful right now, but I do hope that it gets easier in time. You'll see that with the Spin Rust SDK, we're just applying a macro to our function. This does all the boilerplate for us, meaning all we have to do is work with a function that has a request as a property passed in. We can access the headers, and we have a response builder, making this super easy to work with. So I love, excuse me, I love the Spin SDK for Rust. So we don't need to worry about headers or query params or path parameters at the moment. We just need a new JSON response. So we're going to return a 200. We've already got an example header passed in by the boilerplate. So I'm going to set this to content type, and I'll let Copilot do application JSON. Thank you. And we'll say hello world like so. Now this won't work. It's not JSON yet. So let's do a spin build, and this is Cargo. It's not too big, it won't take too long. And spin up. Now go back to challenge 1 Rust. We could do curl localhost 3000, and we get hello world. Of course our test case won't pass yet because the JSON response is not a JSON response. So how do we tackle that? Well, we could make it very hacky. We could use a raw string like so, like we did with Grain. We can just force JSON. However, Rust has a very vibrant ecosystem of stuff. Oh, this is just complaining because I forgot my into. There we go. Rust has the entire crates ecosystem. We have Serde for doing JSON serialization. So actually, what we could say here is that, well, we want a struct called response payload, which has a message, which is a string. And we can say that we want to derive, and we can say serialization. Now, this device, oh, my typing. Derive. But derive doesn't exist yet, or at least the serialization stuff doesn't exist yet because we don't have Serde JSON or Serde with the derive features. So we can come over here, say cargo add Serde JSON and Serde. And you'll see that we get the default features for Serde JSON and the default features for Serde. We actually want this derive feature. So we're going to pop open cargo.toml and come down to Serde, and we'll expand this so that we can specify the features like so. And here I'm just going to say derive. Now Rust Analyzer is already running in the background. You can see the text flicking at the bottom of my VS Code. That's now compiling Serde with the new features. We come in here and I should be able to get a helper that says, nope, okay, I'm going to do it manually. So we'll say use Serde serialize. So serialize. Oops. Cool. Now we have a struct which we can serialize to JSON. So let's do well, thank you Copilot. Let's create our response payload with what we expect, which is to have a message key with hello world. Now, as our response, what we want to say is Serde JSON, and we'll do from no, it's to string, and we pass in our payload like so. Now this is still going to complain, and it's because we still need to do our into. And this is going to complain because we need a reference. Nope. What did I do wrong? When in doubt, let's see, what is this type? I swear I did this before. 30 JSON to string, pass in our payload, and we get a result error. So we could unwrap this in line, but of course we should probably do this a little bit nicer. So why don't we do a match? We do a fill. And this gives me my string. So this is my JSON response. If this does fail, this is just returning a message. Of course, that should never fail. I don't even know if this is a thing. Nope. I don't know where I got that from. Response. Builder. No. HTTP response builder dot status, and then we can do 500 and then pass the other string back. Okay. Here, and this means our return. I'm still failing miserably. Body JSON response. So now this should update to say that we're passing back a string. This one is complaining because and I said I was doing this because I knew Rust. Let me take a look. Oh, because it needs an OK. I'm gonna come back to you in a second because it's yelling at me. Help. Dot to string. Okay. Now down here, we want to pass back some JSON response dot into. Oh, where am I? Some body close. All right, and it's response. Okay. So that was a long way for a shortcut, wasn't it? However, we have a struct called response payload, which has the JSON structure that we want of a message and a string. We added a arrive macro so that this knows how to serialize it to JSON. Now, we did a JSON to string of this object, the structure, and we could have just question marked it and unwrapped it, but we did this a nice way where we matched. So if there is an error, we're going to fix this response. Otherwise, we return the string, and then down here we build a response like we were with the native hello world, and we're just making sure that we pass back an option type, so a sum, where the body is the JSON payload that we want. And in an attempt of a failure, we can fix this. So this is a OK, where we get a builder, a status, and a body. And the problem with this is that we've got error.toString close. I actually think that should be all right. Why are you complaining? Oh, the sum. Okay, there we go. Make sure I've got this all matching up right. Where are we getting bytes? Oh, this expects bytes. Okay. Phew. So the body expects bytes, not a string. We were passing error dot to a string, wrapping it in an option type, but actually we have to enter it into bytes. However, we got there. So I'm never doing Rust again on a live stream. We're going to do a spin build. We're going to follow. We're going to run a test suite. We're going to celebrate and rejoice, and things will be amazing. And success. Thank you. And thank you for the comment. Rocket. Yeah. I feel like a rocket, but we got there. So our test passed. We can now submit this. So we can run the submission command, which I'm just going to copy again from here. And to submit, we need a new URL. And what you're going to realize here, so you can deploy any application as long as spin build produces the WebAssembly artifact. You can deploy that to Fermyon Cloud. Oh. Try again. Oh, I broke it. I'm not going to worry about that. My test passed. Hopefully you don't have problems doing a Fermyon spin deploy. Maybe it's something in my TOML. I'm not entirely sure. But it worked. My test passed, and that's what's important. All right. Thank you for joining me. What did we do? Well, we introduced Advent of Spin. I have shown you now how to complete Challenge 1 with both Grain and Rust. You can use whatever language you want as long as it has a supported WebAssembly toolchain. If you struggle to get the spin.toml configured for a language which is not part of the spin.new template, jump onto the Fermyon Discord. The link will be in the description below, and we will do our best to help you get that configured with whatever spin.toml requires. Deploy your application after your local test suite's passed. This will avoid any failures with the submission process. So run make test and use the hurl script to make sure that your endpoints are compatible, and then submit with the hurl command in the README. So I wish you all the best of luck. A new challenge is already out. You can look at Challenge 2 today on the GitHub repository, and a new challenge will be out on Friday, as well as my walkthrough of Challenge 2. So thank you for joining me. Have a wonderful day. I'll see you all on Friday. Adios.